In this video, we shall review the flowchart for the DC motor electromechanical device, and then we should look at a similar example. Remember that before you start programming, make sure the arm is in the middle of the device. Then when you finish your program, you can test the arm from anywhere. Following our format that we've been using in class, we'll start with the start-stop section, and then we'll set up inputs and outputs. In our start-stop section, these are push buttons which we've been using. We set up the motor with a holding contact, the direction also with a holding contact. Now I've connected the limit switches to output energized coils, but I'm using B320 and B323 for the addresses, B322 and B323 for the addresses. This just allows us to look at these outputs and quite easily see whether these input switches are closed or open. Move on to the control section. The first thing we want to do is set the direction of the arm to go left. We'll use a 1/4 of a second delay. Remember that in the programming technique we've been using, we've paired the output energized coils with a timer. Next, we'll turn on the motor. And third, if the motor is on and the left limit switch is on and the direction is left, we'll turn off the motor. You have to remember that at this point, the motor is going left. So all we're saying, when it gets to the end of motion, it will hit the left limit switch and that will come on. And so based upon these three conditions, we will turn off the motor. So when the arm gets to the limit switch, we turn off the motor, and then we'll change direction for it to go right, and then we'll turn on the motor again. Recall at this point the motor is moving right. So if the motor is on, that is, something has not blocked the arm, and we get to the end, that means it's hit the right limit switch and it was going right. This direction is really optional, we'll discuss that later. Then we turn off the motor. This time we'll use a 2-second delay just to give the motor time to turn completely off. So for this program, we're starting off in the middle. The arm is going to go all the way left, stop, change direction, go all the way right, and then come to a stop. Between each of these different sections, between set direction, motor on, turn off the motor, we're going to program it a little bit different. In other words, we're going to make sure, for example, before we turn off the motor, we're going to check to make sure the motor is on. Before we turn on the motor, we're going to double check to make sure that the direction is set for right. So we're going to add some additional conditions into our runs. What are some of the other things we must consider? How do we get the arm to go back and forth 5 times and come to a stop? You should be able to use this flowchart and make some additions to get that done. What if the arm is all the way to the right side? Will the program still work? Well, this one should, because we're starting by going left. What if the arm is all the way to the left side? Will the program still work? Well, we may have some other things to add, because we're starting by going left. So how do we make some modifications for the arm to go right? Furthermore, we have to make sure that when the stop button is pressed, the arm should come to a complete stop. Now let's look at an example. Let us review the paired rungs in our control section. Remember, every time we have an output energized, we've paired it up with a timer. This pair combination allows the output energized to behave like a momentary push button switch. So when this contact is closed, this output will be energized. This set of holding contacts will keep it on. We'll use the contacts from these to switch on and off whatever we want to do with that at that point. And then we'll also use the contact to start the timer. As soon as the timer starts, it'll open up this rung, and therefore the push button will be released, and this will be de-energized. And then the timer will go through its time. This is used to reset the count back, the accumulator back to 0. And we use the timer done on the next rung. This method is fine when you don't have any additional conditions on your following rung. In other words, the rung that follows the pair. But when you have additional conditions here, example, if you want to add the fact that motor 1 should be on before we energize the coil for motor 2, then we have a few shortcomings which we have to address. We need to make sure motor 1 is on before we start motor 2. So we're going to have to add a condition in here. What if there are more input conditions here that were required before this output would energize? Then we'd run into a timing issue. So the second modification we're going to make is now we're going to let this contact from this output energizer of the next rung reset this timer. So if there are any conditions here, this timer won't time out before those conditions were fulfilled. We'll also make the adjustments to the next two rungs. So the timer will not start to energize motor 2 until motor 1 is on. The timer will not start to energize motor 3 until motor 2 is on. For the repeat section of our program, since we have nothing after this repeat pattern coil and timer for pair, we'll let this self reset. We've added timers to the motor, so this motor will come on after 5 seconds, this one after 7 seconds, and this one after 4 seconds. Because in reality, Different motors might require different starting times based upon their load. So we try to simulate that as best as possible. We've added different starting times to each of the motors, because you can imagine in a conveyor system we will require the first motor to start, and when our products get to a certain point, then the second motor to start, and then the third one to start. And if the first has not started, then there's no need to start the second, and similar approach will be taken for the third. So this first motor, we're giving it a 5-second start time. The second one, we're giving a 7-second start time, and the third one a 4-second start time. So we can observe now, as the program is running, we'll see the first motor come on, which is output 0. 7 seconds after that, we'll see the second motor come on, and about 4 seconds after that, we'll see the third motor come on. I'd like to make one more addition to this program. If input 3 is on, then motor 3 must not come on. We'd like to do a bypass. To do a bypass, we're going to use input 3. When input 3 is closed, we need to make sure that this output energized coil is not energized. So we're going to use the normally closed and add it in series with the output energized coil. Now this timer was being reset by this output energized. So we'll now use the repeat pattern contacts to reset the timer. So now only one thing is left. How do we get this repeat pattern to energize? Well, since this rung was energized with timer 1 down bit, we'll use that here, and we only want this in play when the motor bypass is closed. So we'll put them both in series, and we should be good to go. Set this time to 6 seconds to give our motor 2 time to remain on for us to observe. So changed the repeat bit using the timer down bit for repeat purposes. It's a push button, so I'm going to toggle that on, toggle it back off. Observe, it comes on, first motor. Second motor comes on. Third motor comes on. Now I'm going to switch on the bypass. First motor comes on. Second motor comes on. Third motor never comes on. It repeats the first one coming back on. That's it.